We're learning about the first derivative test in this section. Two learning objectives. The first is to find relative extrema, relative minimum or maximum of a continuous function using this test called first derivative test. We will have to find the derivative and use that to find relative maximum or minimum in this section. After that, we'll sketch graphs of these continuous functions. Okay, so first couple definitions. A function f is increasing on I for every a and b and I if a is less than b. Well, okay, what did I just read, right? All right, take a look. Let me say that this is a number line, and here's my a and here's my b, okay? Because that's what they said, didn't they? Over here, a is less than b, okay? Which means a is to the left of b. B is on the right side because b is bigger, okay? Now, if I want to sketch a picture that is increasing, all right, I'll just say like somewhere over here on A and somewhere over to B, it has to go up, right? So if that's the picture, then we know a function is increasing. So how would I write that down in some notation? Notice the function value for B is higher than the function value for A, right? So say that we get to say function is increasing if the function value for A is smaller than function value for B. We got bigger. We went up higher, okay? So now, the second part, we're just going backward, right? Let's say that we have A and B. Here's my A, here's my B, okay? Still, A is smaller than B, right? But if we want to make it a decreasing function, we should start from somewhere high and we need to go down, right? So what will happen is the function value at B will be lower than the function value at A. So say that f of A, the starting point is higher than the ending point, okay? So that's the definition of increasing and decreasing, okay? Now, we can connect this to slope of a secant line. For an increasing function, you notice this is increasing from left to right, right? If you plot a point on the left and plot a point on the right and connect them with a straight line, you can see that the slope of this red line is positive because this is going up from left to right. If you look at this other case, as you can see, this function is decreasing from left to right. If we start from a point on the left, going to the point on the right and connect those two dots with a straight line, what happened? The slope of this blue line is definitely negative because this is going down, right? So what we're going to do is whenever we run into problems where they ask us for where is it increasing, where is it decreasing, we will find the sign, whether it is positive or negative, of these tangent or secant lines, okay? So that's how slope of a secant or tangent line relates to whether function is increasing or decreasing, okay? Increasing, slope is positive. Decreasing, slope will be negative, okay? So let's look at this theorem over here. Let f be differentiable over an open interval I. If f prime of x is positive, so now take a look. What are they saying over here? That the derivative is positive, that the slope of a tangent line is positive. That's what they're saying in that red highlighted part. Then, guess what we can say? F is increasing over I. Going up from left to right, so the slope of a tangent line is positive. Now, what if the derivative is negative? Okay, what if f prime of x is smaller than 0? We're looking at negative numbers, right? We're talking about slope of a tangent line being negative in this case. If that's the case, what do we know about the function? The line is going down from left to right. Okay, that's what a negative slope looks like, right? So we get to say that the function f is decreasing over I. And I think that's it for this first page, but we will look at some more examples and get to talk about the first derivative test in the following pages.